Okay, so for chapter 7, we're going to be working on adding, subtracting fractions. So lesson objective for tonight's homework is understand a fraction a over b when a is greater than 1 as a sum of fractions 1 over b. Understand addition and subtraction of fractions as joining and separating parts of referring to the same whole. Okay, which is just fancy words that you can't add and subtract without common denominators. All right, so two very important vocabulary words is mixed number. Mixed number is an amount given as a whole number and a fraction, just like 2 and 1/2. Two whole, like 2 whole pizzas and then a half a pizza. Okay, so you got whole numbers and fractions. That is a mixed number. A unit fraction is a fraction that has a numerator of 1, like 1/2 or 1/3 or 1/4. The numerator will always be 1 in a unit fraction. All right, so make sure that you pause the video here and write these down in your notebook. All right, let's move on. All right, so here's our first problem. Mrs. Clark has the following pie pieces left over from a bake sale. She will combine the pieces so they are on the same plate. How many pieces will be on the dish? Okay, so basically we have 1, 2, 3, 4, 5, 6. So 6 is my whole on both of these. I've got 3 of them shaded here and 1 of them shaded here. Now I want to combine them onto the same plate. I'm not sure why I didn't have another plate here, but I don't. Okay, so that's ugly. Let's try that again. All right, that's better. Okay, so I want to take all of these pieces and I want to add them together. Now, my denominator is not going to change. I'm still going to have 6 pieces to the pie. Now I'm just going to color in the shaded pieces. So on this first pie, I have 3, right? So that matches this first one. And in the second pie, I have 1. So I'm just going to add in, we'll color it a different color so you know. I'm going to add in 1. So how many pieces will be on the dish then? So I have 1, 2, 3, 4 pieces on the dish. It's really simple as long as you have the denominators the same. Okay, you just add the top number. 3 plus 1 equals 4. All right, so second part of that problem, because we always have to have multi-step problems. Suppose Mrs. Clark eats 2 pieces of the pie. How much pie will be left on the dish? Okay, so if she's eating 2 pieces, we are now subtracting. So we had our pie, right? When we added the pieces together, we had 4 colored in. Okay, so this is 4 over 6. And she's going to eat 2 pieces. Right? She's going to eat 2 pieces. So minus 2, 6. So let's take 2 of these away. I'm going to color in blue because that's going to take them away. And so that leaves me with how many? 1, 2. Okay? Denominators are the same all the way across. And 4 minus 2 is 2. Okay? Super simple. All right. Let's take a look at another problem. Kevin says that when you combine 3 pieces of pie and 1 piece of pie, you have 4 pieces of pie. Explain how Kevin's statement is related to the equation. All right. Well, again, if you look at this equation, you have 3, 6 plus 1, 6 equals 4, 6. Why is that? Why does that relate to each other? Okay. Well, an explanation would be that you add the pieces of the pie together. So in the equation, (3, 6 plus 1, 6 equals 4, 6) because 3 plus 1 equals 4 and the denominators, oops, that should be a 6. because the denominators are all the same. All right. Let's see here. Let's look at another one. All right, Isabel wrote the equation 1/2 plus 1/6 equals 4/6. And Jonah wrote 3/6 plus 1/6 equals 4/6 to represent combining the pie pieces. Explain why both equations are correct. Well, let's start with the most simple one, the one that we've been working on. 3/6 plus 1/6 equals 4/6. Okay, so here the denominators are all the same. Make sure that they're all the same across. Okay, and we know that 3 plus 1 equals 4. Okay, so that matches up just fine. But here we have 1/2 plus 1/6 equals 4/6. But we don't have the same denominators here, do we? We have a 2 and then a 6 and a 6. So how do we fix that? Well, remember, if we convert this to an equal denominator, we can change this to a 6. 2 can go into 6 by timesing by 3. And what we do to the bottom, we do to the top. Okay? So 3, 6, and 1/2 are exactly the same. Now, we can prove that 3/6 plus 1/6 equals 4/6. Because now we have the same denominator all the way across. And 3 plus 1 equals 4. Okay, so you would just put that into words when explaining. All right, last one. If there is 4/6 of a pie on a plate, what part of the pie is missing from the plate? Write an equation to justify your answer. Okay, so all they give us is 4/6 of a pie is on a plate. So first thing you could do is make your diagram, right? Draw your pie. So we have 4 of them. 2, 3, 4. Okay, so I have 4/6 on a plate. And what is my whole number? If I had a whole pie and it was full, what would that look like in a fraction? Because I can't go 1 minus 4/6. That doesn't work. Because we got to have the same denominator. So what is a whole pie in sixths? It's 6. Okay? And to find out how many is not covered, I would just subtract. So 6 minus 4 is 2, and the denominator will stay 6. And I can see that in my picture also. So my equation would be this. 6/6, or 1 whole, minus 4/6 equals 2/6. The most important thing to remember when adding and subtracting fractions is to make sure you have the same denominator. And if you do not have the same denominator, you need to convert it. Okay, so if I have 3/4 plus, let's see here, 2/8, I got to convert them to 8s. I got to find common multiples. Okay, so this will go to an 8. This can stay the same. 4 times 2, and then 3 times 2. So it'll be 6/8 plus 2/8 equals 8/8, or 1 whole. Sorry, smartboard's messing up. Okay, so hopefully that makes sense. Super important you remember same denominator. Okay, if you can remember how to make them the same denominator, then you won't have any problems with adding and subtracting fractions. All right, let's take a look at our homework. Here they're using models, so it shouldn't be too hard for you to follow along with using models. Okay, so for example, we've got a pie here with 8s. 3 of them are shaded here, 2 of them are shaded here. 3 plus 2 is 5. I can also count. Okay, but making the equation is what's important. You got to be able to make the equation. All right, when you see something like this, this is subtract. Okay, so I count. Let's count. I have 1, 2, 3, 4, 5. So that's my whole. That's going to be my denominator. All right, and they want me to take out 3 of them. So I have 1, 2, 3, 4 shaded. 4/5 are shaded. Minus 3 of them equals how many are left shaded? 1/5. Okay, does that make sense? So let's take a look at that again. So I'm going to count. I have 5 of them. 1, 2, 3, 4, 5 is my whole, my denominator. I have 1, 2, 3, 4 shaded, and they want me to take out these 3. So I have 4 shaded minus 3 equals 1. Okay, so don't get confused because this is not part of it. That just helps me figure out what my denominator will be, my whole number. Okay, because remember, fractions are part over whole, part over whole. Make a note of that somewhere. Part over whole. Really important. All right, let's take a look at what other one I want to do. I think I want you to try these other ones on your own because I think you guys can do it. So count the holes. How many are in this square? And that's your whole number. How many are in this total? And this is subtracting. Okay. Total is your denominator. All right. And actually it looks like it gave it to you, but why is this 3/5 plus 2/5? Maybe we're not subtracting. Maybe Miss Friendly just lied to you. I do that all the time. Let's check, because now I'm confused. Because number 5 should be subtraction. Yeah, this is subtraction. So looking at this right here, this is supposed to be subtraction. 3/5 minus 2/5. So that should be a subtraction problem. 3/5 minus 2/5 equals. Okay. All right. So your WSQ for tonight is Bella brought 8/10 gallon of water on a hiking trip. She drank, which means subtract, 6/10 of gallons of water. How much water is left? Have a good night. We'll see you in the morning.